Okay, I nearly forgot. You've looked for data points that sit outside of where they should, so things that are below the scores possible, things are above the scores possible. The other thing you need to make sure of with particular regard for question 1 to 52, because you're going to create some scores, is the missing data. So you go analyze descriptive statistics frequencies, put all of, so we don't need those in there, put question 1 to 52 in there, statistics, just minimum, maximum, same as before, it's just, I'll show you again anyway. Don't need any charts, format, who cares, and press OK. And you end up with, this point here from last time. We also end up with this, and when you scroll through here, this will actually tell you if there's missing data. So it's actually told you how many of each, how many people actually kind of chose each of the options. As you scan through here, you'll go extremely important, extremely important, extremely important. We'll find one in a minute. Okay, missing. Okay, so we know that question 1 has a missing data point. Now, we've already explained how to deal with a missing data point, so take the average of the other 3, but you need to go and find it for question 11. Sorry, not question 1. See if we can find another one. Extremely important, extremely important. That might be the only one. But yeah, your data might be different, so don't just assume that. Yeah, that should do. So then go and fix it in exactly the same way. So you want to make sure there's no missing data, because otherwise that's going to mess up your scores. All right. Okay, factor analysis. Now, I think most of you will have actually been in the tutorial and heard this explanation before, but basically when we've got a scale of 52 items, we don't want to look at each and every one of these items. That's ridiculous. These items, there are multiple things basically measuring the same idea from different perspectives. So what we want to do is we want to work out whether they all sit together nicely. So you think if I've got a bunch of items to measure whether you enjoy university, and I ask a series of questions about, do you enjoy lectures, do you enjoy tutorial, do you enjoy working at home, and then I ask you, do you enjoy the lunch? I know you've probably heard this story before. Then what I will probably find is that do you enjoy lunch doesn't actually relate very well to the other 3 variables. And so what a factor analysis allows us to do is to work out how different variables relate to one another. Are they highly correlated, because you want them to be highly correlated, and are they separate from other things? So this scale, when you have a look at the WAPS admin, it's got these different items, 1, 2, 3, 4, however many, 13 items. So what we want to see is that in the first stage, we want to see that the numbers identify that it's actually picking up 13 different things that sit separately from themselves. And then in the next step, which is a reliability analysis, what we're going to see is to make sure that each of these items hang together nicely. Okay? So you may find that you have to do this a couple of times if you've stuffed up your data cleaning or anything like that. And I haven't fully cleaned my data, so we're just dealing with some kind of messy numbers. But if you've stuffed up your data cleaning, you might have to go back and fix that. So you need to get that sorted out. All right, so what we're going to do, factor analysis, is we're going to go analyze dimension reduction factor. Okay, so we're not interested in these first 5 at the moment, we're just interested in these 52. So we're going to grab these 52 and we're going to put them over there. So what we're saying to SPSS is, SPSS, we've got 52 items, we want to know whether they create a set of I guess, ideas that kind of chunk together. So then we go click on descriptives. What we want to choose is in the statistics section, we want to make sure that the initial solution is ticked. Statistics, initial solution. Now remember, I'm just reading this stuff straight out of Paleo, so you can do the same. I don't rely on memory for this stuff, and most of us don't. In the section marked correlation matrix, coefficients and KMO, so KMO and coefficients should be chosen, and Bartlett's and KMO are in the same thing. And then continue. Under extraction, we've got in the method section, we want to choose principal components analysis. Method, principal components analysis, it's the preset anyway generally. Sometimes it varies, so make sure you always double check. In the Analyze section, we're going to choose the correlation matrix. So that's going to spit out a correlation matrix for us so that we can have a look at that. In the Display, we're going to choose the scree plot. That's really important because that's going to help us make a decision about how many factors there are. And make sure the unrotated factor solution is ticked. Unrotated factor solution there. And then in the Extract section, we're going to choose based on eigenvalues greater than 1. Now this will make a bit more sense in a minute, but basically this is the way that we decide whether something is a factor or not, whether a group of variables actually hangs together. And we're going to go, and this, you may or may not come back to this, but if you find that it doesn't create one of the tables, which I'll talk about in a minute, you can actually change this, but don't worry about it for the moment. So then continue, rotation. We're going to use, so in the rotation button, we're going to choose the direct obliment. Now, if you want to know exactly what that is, good for you. You can look it up, read the instructions. There are different techniques for different types of data. But basically the direct obliment assumes that there is some level of correlation between the factors, that they're not entirely separate, which is often the case for psychological type data, human type data. Then in the options, then we probably need to continue. In the options, there's lots of buttons to press. The good thing is that once you've done this once for this analysis, if you find that you stuff something up, it will hold on to all of your other things, so you don't have to go through each one. So we want to exclude cases pairwise. We want in the coefficients display format, we want to say sorted by size. This just makes it easier to read, and suppress small coefficients. So what this does is it means that you're only looking at numbers that are above 0.3, okay? Now this will make a lot more sense when you actually have a look at the table, but it's not that there's not coefficients for the other ones, it's just that we're really not interested in anything that's below 0.3. And then continue, and okay. All right, now you have to wait a little while. All right, so whilst that might be slightly bewildering, don't worry about it. It's not a big deal. So the correlation matrix is it's just a correlation table. Now, doesn't matter too much, but let me show you a trick. So if you select this, copy, this is using Excel again, create a new, just get rid of all of that. You should be saving it or starting a new one, but I'm just going to delete it. Now, if you paste that table in there, right, it means we can actually do something to it. So let's select all of the numbers within the table. Okay, now this technique of formatting is something that you can use in a lot of different settings. So you've got heaps of numbers here, and what you want to do is you want to identify all of the numbers, you want to easily and quickly identify all of the numbers that are less than negative 0.3. So it's a reasonably strong or moderate correlation, so less than negative 0.3, and all of the ones that are greater than positive 0.3. And there's a really easy way to do this. For this particular exercise, it's not actually that important, but you will find later on when you're exploring data that this process is really helpful. This is just something I've found really helpful that someone showed me. It's not part of the course. So conditional formatting, new rule. Now what we want to do is format only the cells that contain. Now cell values between, let's go less than negative 0.3. Okay, so this is going to choose, it's going to format however I tell it to, all of the values that are less than negative 0.3. So we're just going to look at the fill. Let's make them orange. We'll go OK and OK. That wasn't very helpful. All right, let's try. So that it seems as though there's nothing that's less than negative 0.3. That's fine. New rule. Cells that only contain cell value above, greater than, whatever, 0.3. Format. Let's make it green. Okay. Okay. All right. So now when you have a look at this, obviously the ones, you probably can't even see that, the ones are where each data point is correlating with itself. So it's a 1-for-1. You know what that is. But all of the others, so when you have a look here, it seems as though question 1 correlates quite nicely with question 13. Question 2 correlates quite nicely with question 14. Now what else you'll notice is that question 1 also correlates with 25 and 37. Now if you think back, the reason this is interesting is 1, 13, 25 and 37. How beautiful is that? So basically what this is saying is we've got correlations between our scores that we're assuming are fitting together, and that's exactly what we want to see. So then when you zoom out, you can actually see this cool pattern that yes, whilst there are some things missing, that we've got this basic pattern that the scores are loading together. Now, you can use this function in all sorts of different things, and you're probably not going to use it for this. Really, all you need to do for this particular part of doing your factor analysis is have a look at this and go, do we have some correlations above 0.3? Right? So when you have a quick scan over, you have a look and you go, 0.329, 0.413, yeah, we've got some, we should be okay. So that's basically all you need to do for that one. And have a look at Palant, it actually explains it. Basically, you just want something to correlate. If nothing correlates, then it means that none of those factors, none of those scores are going to hang together. Okay, so Kaiser. Now, if you want to understand these, Google it yourself. If you have basically the benchmarks for all of these. So the benchmark for the Kaiser-Meyer-Olkin is 0.6. You want it to be above 0.6. So you can go, yep, good. And what you'll do is you'll actually report the KMO was above the recommended 0.6, and you'll cite Palant, because Palant makes the rules. Remember, statistics is all about blaming somebody else for your choices, or, citing someone else for your choices. So you want to, say who said it was above 0.6. Significance, what you want, Bartlett's test is significance, you want this to be below 0.05, it's 0.00, which is fantastic, that's exactly what we want. Then, when we have a look here, what we see is that we've got 12 factors. Okay, now remember that yours might be different. I haven't fully cleaned the data, I'm just showing you how to do it. So what this tells us, so the reason we know that there's 12 factors is because everything with an eigenvalue above 1 is classified as a factor. Okay, remember when we chose eigenvalues above 1? So these are the eigenvalues. Everything above 1 is classified as a factor. So this tells us that there's 12 factors, right? Now, there's more than one way to decide whether, to decide the factor structure. So basically, when you have a look at this document doesn't actually give us any details about whether they've done a factor analysis. So what we're doing is we're saying, well, it's all well and good for you to say that there are these 4 items and they hang together nicely and that they're all separate, but you haven't actually, it doesn't appear that you've actually done the statistical analysis. So this is us doing the statistical analysis to see whether it fits the structure that they've proposed. Now, you can decide to have a different structure to the original scale, but generally it's recommended to try, as best you can justify, to follow the original factor, because that scale has been used in lots of different places. So what we're hoping, really, is that it follows the same kind of structure. Okay, so the first thing we look at is the eigenvalue. 12 factors. We have a look at this, and just out of intrigue, we have a look at the WOPs and we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So already we know that there's something slightly different going on. Okay, so we're going to check into that. Now the scree plot. So these are just different ways of kind of looking at the same thing. When you have a look at the scree plot, what you want to identify is there's basically a straight line from here through over this way. And what we want is the point at which it starts to turn up, everything from that point onwards, so let's say it was this one here, I know you probably can't see it, but anyway, upwards is considered a factor. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in this instance, the scree plot basically agrees with the total variance explained. Okay, so that tells us that we've probably got 12 factors, even though the original scale said that we had a lot more, or had one more, sorry. And if you have a look at Palant, it gives you a simpler scree plot where it's very, very clear as to where it is. But often it's the case that you end up with this gentle curve and you've got to make a decision. So the fact that we can make a decision and it agrees with the eigenvalues means that, yeah, maybe we should go with that. But it's up to you. You just have to justify what you're suggesting. Now, for the moment, we can ignore this one. Now, we've noticed here that rotation failed to converge in 25 iterations. So, the pattern matrix, we want the pattern matrix. So let's go back and see if we can get it to converge. I know this seems a bit strange, but basically it's tried to do something 25 times and it hasn't converged. So we can actually go, well, maybe you should try a little bit harder. And we can just change it to 50. So it's still doing the same process. Change it to 50 and see what happens. Okay. Okay, so all of that should have stayed the same, but then we have this pattern matrix, okay? So when we have a look at this pattern matrix, we notice that they're not neat and tidy, right? So there are some problems here. So the first four, that's 4 items, and 31, 19, 7, and 43, I'm going to take a wild guess that that is actually accurate. 31, where are we? 19, 43, and 7. So that's prestige. So that's come up nicely. But this one has 6 items, okay? So again, let's take this into Excel, because that just makes life easier. Create a new document, paste it in there. And what you want to do is, if you, for those of you who don't know this, if you want to split, so when it's open fully, it takes up the whole screen. If you're not lucky enough to have 2 screens, grab the top bar and then drag it across until your cursor hits the edge. I know most of you already know this, but I'll tell you anyway. And then it will split the screen. Then what you can do is open up the WOPS scoring, grab the top bar again. This works in just about any program, and then across. So then you can look at both. You can get rid of this, press a little arrow. So now you know exactly what's going on here. So let's go through and see whether these fit nicely together. So the first one, we've already checked this one. All right, green means go. Green, so we know that that's okay. Okay, let's have a look at this next one. Starting from the top, 18. So let's have a look for 18. Where are we? Can't see if we're looking. 18, 6, 18, 30, and 42. 18, 30, 6, and 42. Okay, so it looks like these are holding together nicely. All right, but we've also got this addition here of 49 and 406. Okay, so let's ignore that for the moment. Let's just do the easy bits first. Always a good philosophy. The next one, 22. Okay, so we've got, I found it a second ago. 22, 10, 34, and 46. 22, 10, 34, and 46. All right, so the first 4. And remember before we chose to put them in order from greatest to least? This is why, because it makes it easier when they're in order. The stronger relationships are closer to the top. Okay, so again, we have some issues here. We've got some extras that are loading together. We'll have a look at that in a minute. Let's have a look at this one, 21. 21, 33, 45, and 9. 21, 33, 45, and 9. That one's a good one. Nothing else seems to be loading, although it could be, yeah, so we've got one down here. So if you think each of these columns are factors, in fact, you can actually go through, and when we have a look at this one, question 31, where was it? Is prestige. You can actually change it as you go, just so that you keep on top of it. Prestige, so that you can keep a track of what's going on. So each of these represents a factor. And what we're going to do is, once we've sorted out the problems, is we're going to add these up so that each of these represents one score rather than multiple scores. 3, let's find it. 3, 15, 27, and 39. 3, 15, 27, and 39. Fantastic. This is what we want. We want it to match the original scale. 38, 38, 26, 14, and 2. 38, 26, 14, and 2. Sometimes it makes it much easier to talk out loud in your head, because then you remember the numbers for longer. You guys have been doing psychology and long enough to know what's going on there. 12. All right, 12, 24, 36, and 48. 12, 24, 36, and 48. So I see by doing the numbers, it just helps you keep a track of it. 32, 32, 44, 20, and 8. 32, 20, 44, and 8. Yep. So everything seems to be working nicely. That's good. It's going to get messy down here though. Okay, so 47, 47, 35, 23, and 11. 47, 11, 51 doesn't show up there, so we've got a bit of an issue there. Let's highlight those two, they're together. Let's just have a look. So what have we got? 11. So we've got 11 and 47. What we haven't got is 24 and 35. So let's see if we can find them. Are they in the same column? So we have a look here, not that one. 35 is. Okay, so when you have a look at that, it's loading on this one, but it's loading stronger here, but we don't really want it here. So let's highlight it for this one and keep it in this category. All right, so that was 35. What was the other one? 23. So 23 is not. It doesn't seem to be picked up with this one at all. So that's going to be a bit of an issue for us. All right. Okay. So we've got 3 items there. We're not sure what's going on. We can get stuck into that later. All right. So 50, 51, 52, 49, 50, 52, 49. What was the other one? 41. Okay, so these 3 loading together. What are we missing? 50, 49, 52. So 51 is the one that we're missing. Is there anything in this column? No, there's not. So for some reason it's showing up here. It's not showing up there. That's okay, we can check that later. 41, it's a bit tedious listening to me do this, I'm sure. 41, 29, 17 and 5. 41, 29, 17 and 5. Thank goodness for that. Getting bored of finding wrong ones. And then 13. There's number 13. Here we go. 13, 1, 37 and 25. Beautiful. Okay. So we've got a couple of issues, but basically it's all okay. So we're not sure what this is. So what do we got? 40. Where is that supposed to sit? 40, 16, 28 and 4. Okay, so that's interesting. So their creativity is loading at this on the same as 22 management. Okay, so I'm not sure why they're separate, why they're together, but they're loading on the same thing, but they're still holding together. So you have to make a decision. You're going to have to make a decision as to how to bring these together. So you have to basically justify what you're doing. If you decide to use a structure other than what they've used here, you need to justify it. So if you wanted to bring these 2 together, you need to have a look at those questions and say, okay, these are loading together and they're very similar ideas, and so perhaps this is actually more about creative management. I'm just making it up. Don't use that. I haven't looked at it. But perhaps they're all about creative management and there's a lot of crossover between the 2. Or you might decide that no, you're going to keep the original factor structure, and that's okay too. But you need to make the decision and justify the decision. Same with here when you've got scores that, so this one's okay, it's loading on this same one, but what are you going to do about the one that's not supposed to be there? So have a look at Palant about how you justify that. And basically what that tells you, that gives you the instructions, it justifies creating a sum score for each of these factors. So you might go through now, and in the next stage, you'll go through and you'll actually create a sum score for each of the factors. All right, so hopefully you've got that sorted and that makes sense. Okay, so in the last one we did factor analysis and we kind of worked out that, okay, we're basically following the factorial structure of the original WOPS thing. Now remember, that's your decision, and I'm not going to create scores for all of these. I'm not telling you which way to go. You need to decide and justify whether to follow this original structure, because you can justify it using this, which is valid, or whether you're going to follow a new structure because of what you've found here, and that's valid as well. And remember too that the numbers that I'm using are going to be slightly different from yours because I haven't actually finished cleaning the data. So don't freak out if you're looking at this and going, wow, how come mine's so different? Just make sure that you're following all the processes that we've given you, and keep going back to Palant and making sure that you've cleaned your data properly, that you've worked everything out, that you've clicked all the right buttons. Good rule of thumb, the book is never wrong, okay? Now the reality is that it is, but you will never find it because neither you nor I are smart enough at this point. So assume that the book is right and that you've just missed something. Then you'll do much better in this, even if you have to do it 4 or 5 times. You'll be great at it if you do it 4 and 5 times, because practice makes perfect.